Alright, so question 1C on your page says brackets negative 11. Very first page. Minus 4.
17. Oh no, the first page. Solution.
Sorry, minus negative 4. No, this one's different. Minus 18, minus negative 7.
Minus 12. Oh yeah, that's very good.
What do we say? Minus, oh sorry, 12?
We're almost there, sir. We're so
Hey,
close.
there you go. Minus 12.
Nobody else.
Make that a 1. Minus bracket. Plus negative 7. Oh,
No, we're doing all minuses. Mainly because I want you guys to get used to subtracting a negative. Okay? I'm quite sure you guys know how to add two positive numbers. So when we go through this, we're going to do these. Okay? We'll do them two at a time. We're going to deal with negative 11, subtract negative 4. So I want you guys to think of multiplication rules. If you guys remember multiplication rules, if I have a positive times a positive, I get a positive answer. If I have a negative times a negative, I get a positive answer. And then when I have two opposites,
Negative.
the negative.
Oh, I saw that too.
Positive.
I saw that too.
It's because you're standing in front of the sensor.
We get a negative answer. So, with keeping that in mind, we have a negative and a negative beside each other. So we're just going to try to simplify a question. We have two signs beside each other, and there's no number in between. We'll simplify the question so it's easier for us to read. So a negative and a negative can be turned into just one sign, which is a positive. Now I know these are adding and subtracting questions, but we can use our multiplication rules to simplify the operations. So this negative 11, and we have a subtraction and another subtraction sign, we're going to combine the two and make it plus 4. Okay? And I'm only dealing with the first two to start. So this question looks like negative 11 subtract negative 4. Can also be read as negative 11 plus 4. Okay? I'm going to go along through the rest of this question. I'm going to do that for any time I have two signs beside each other, just to simplify. So I still have minus 12. There's only one sign. Again, I end up with two signs here. Subtract negative 7. That means I can combine the two signs and make them a positive. So we get plus 7 minus 18. Okay? Now I don't have so many operations in the question. It's more simplified. We can work on these numbers. Negative 11 plus 4. There we go. Good. Negative 7. Minus 12 plus 7 minus 18. Negative 7 minus 12. Negative 19. That's right. Good. Plus 7 minus 18. You guys notice I'm just going through the question and I'm continuously dealing with the first two numbers. Those two numbers, we're going to do it the first two numbers again. Negative 19 plus 7. Negative 12, I heard it somewhere. And finally, negative 12 minus 18. Negative 30, good. Okay, so for 5b, we need to follow the order of operations. In other words, we need to deal with bed mass. This can be looked at as a fraction. It's also a division sign between the two. So what we're going to do is I'm going to work on solving the top part of the fraction, or the first part of the division question, and the second part. Once I get those two answers, then I'll divide the two of them. Okay? So let's start with the top numbers. Negative 18 plus 6.
Negative 12.
Good. Negative 12. Divided by negative 3 times negative 4. I'm going one step at a time. If you guys can do several operations in your head on the paper in one move, that's fine. But I'm doing this step by step so you guys see every part of the question. Negative 3 times negative 4. You guys remember the rules? Negative times a negative. So we have positive, so 3 times 4 is 12. So we're going to have positive 12. Negative 12 divide positive 12. So, our rules with a negative times a negative, positive times a positive, and a negative times a positive are also the same rules with division. So, right now I have negative 12 divided by positive 12. So, a negative divided by a positive will be a... Not sure? I'll write the rules again. Ready? Negative times a negative is positive, and finally, negative times positive is negative. So, if division rules are the exact same, and I have a negative and a positive, my answer is going to be what? Negative. Negative, good. And then I have 12 divided by 12. Anyone know?
Negative 1.
Negative 1. Good. So, 5b, our answer is negative 1. There you go. Okay, so example number 1 gives us 3 fractions, and we're adding and subtracting them. First fraction is negative 2 divided by 5. That's an addition sign. Plus 3 divided by negative 2 minus 3 over 10. So, whenever we're adding or subtracting fractions, the first thing we need to do, anyone know? No? Yeah, we need to find a common denominator. The lowest one makes it easy, but it can be any common denominator. So in other words, what we're saying is these numbers on the bottom all need to be the same number. Okay? Right now I have a 5, a 2, and a 10. I can't work with those. So, I need to find a common denominator between all of these. One way to do that would be to take all the multiples of the numbers. Multiples are numbers that number is multiplied by in a larger range. So, 5 times, for example, 1 is 5. 2 times 1 is 2, and 10 times 1 is 10. But we know that's not a common denominator. That's not going to work. All right. Times 2. 5 times 2 is 10. 2 times 2 is 4. And 10 times 2 is 20. Well, one thing I've discovered already when going through these multiples is I have a 10 and a 10. Okay? So I'm going to see if I can get my 2, and if it will also go into a 10. So if I continue down this road, 2 times 3 would be 6. 2 times 4 would be 8. And then 2 times 5 is 10. So, what I've done now, I've got the 10. I found the lowest common denominator between all of these. The number 10. 5 goes into 10, 2 goes into 10, and 10 goes into 10. Now you don't have to set it up the way I did here. I set it up a very long way. You may be able to recognize just by looking at these numbers that 5, 2, and 10 all go into the numbers 10. But we're going to have to change the first 2 fractions so that they have a denominator of 10. So we're going to rewrite them lower down on the page. Okay. So here's our question again. And we discovered that all these numbers go into 10, but in order to change the bottom of a fraction, I have to change the top of the fraction too. So whatever I multiply or divide the bottom by, I have to do the exact same to the top. So, in this instance, I know that if I multiply 5 times 2, I'm going to end up with 10, and that's what we decided our common denominator was. So I'm going to have to multiply the top of this fraction by 2 also. So, this first fraction, when I multiply the top and the bottom by 2, I'm going to end up with negative 4 over 10. Okay? So that's one of the fractions. The next fraction, I have 2 on the bottom. I know that I need to multiply the 2 by 5 to get the 10. And if I do that to the bottom, I have to do it to the top also. So, the other fraction will be plus 15 over, and don't forget there's a negative there. So negative 2 times positive 5 would be, what is it? 2 times 5? 2 times 5? 10, there we go. Good. Great. Right, negative 10. And finally, the common denominator is already 10. The denominator on this fraction is already 10. So we're going to leave it at 3 divided by 10. So our denominators are the same. But there is one little thing that looks a little odd here. I seem to have a negative 10. The other ones look like they could possibly be positive. Well, this negative actually applies to the entire fraction. This entire fraction is negative. Okay? So I want you to think of it just like the question we've done before, where it's going to look more like this. Negative 4 over 10 plus negative 15 over 10 minus 3 over 10. Okay? That negative, whether it's on the bottom or the top, applies to the whole fraction. So think of that as being a negative fraction. And remember what we did before to simplify adding and subtracting. If I have two operations beside each other, positive and a negative, let's try to combine them to make one. So if you guys remember from that rule we wrote before, if I have a positive and a negative together, I can combine these two to make what? A negative. So I'm going to rewrite this question again. Negative 4 over 10 minus 15 over 10 minus 3 over 10. Now it's a little more simplified. We have a common denominator. There's only one operation between each number. And finally, I can get to solving this question. So I'm going to deal with the first two numbers again. The first two numbers say, let's also talk about our answer, since we have our common denominator now, is always going to be that denominator when we're adding or subtracting fractions. We're always going to have a 10 on the bottom, whatever that common denominator is. So, I already know my answer is going to have a 10. I just have to figure out what negative 4 subtract 15. Anyone know? Negative 19. Great. So I have negative 19 over 10, and we'll just bring down the rest of the question, minus 3 over 10. Same idea. Our answer is going to have a 10 on the bottom again. Negative 19, subtract 3. Negative 22. So our answer is negative 22 divided by 10. Now in this question, I think they didn't care if we kept it as a fraction. We can reduce it. We have negative 22 divided by 10. Can you guys think of a number, a common number that is divisible by the top and the bottom? 2. I can divide the top by 2 and the bottom by 2 to make this a more simplified fraction. So 22 divided by 2, still keep it a negative, it's 11, and 10 divided by 2 is 5. So I'm with negative 11 over 5. If you look on your sheet, that's the very first example. I did it in many more steps. I think they only took 3 to do it. But I showed you every single step there was to this question. Okay? If you can do it in 3 or 2 or 1, that's fine. But if you get confused, it's much easier to go through every step. That way, if you make a mistake, it's easier to see where you made your mistake in the question. So let's take a look at this one again. Last example, we're going to multiply and divide sets of fractions, okay? Multiplying and dividing fractions is usually a simpler process than adding and subtracting them. We don't have to change the denominator. It can be whatever number it wants to be, okay? We don't have to change two operations beside each other where we have a multiplication and a negative sign or a subtraction sign. Because they're not a negative and a positive, I don't have to change any of that. Just think of this being a negative fraction, this being a negative fraction. Okay? So we have a positive fraction multiplied by a negative fraction divided by a negative fraction. Okay? So, first thing I'm going to do is I'm going to deal with multiplying fractions. Okay? Now, it looks like the negative's on the top of this fraction. This negative, I need to apply it to either the top number of the fraction or the bottom one. It doesn't matter. We're still going to end up with the right answer. So you get to pick and choose. Don't apply it to both, though. If you apply it to both, what that looks like is a negative divided by a negative, which makes the fraction a positive, which is not the case. This is a negative fraction. So I know I've said a lot, but I'm going to start working through this. So when we're multiplying fractions, all I have to do is multiply the top numbers by each other and the bottom numbers by each other. Okay? So I'm going to assume this negative's on the top of the fraction when we're multiplying. 3 times negative 4. Anyone know? Negative 12. Good. 4 times 5.
Uh-oh.
Alright, 20. Okay. Just want to make sure you get what to do. So I've done the first two fractions. Simple as that. It's negative 12 over 20. Got to bring down the rest of the question. Divided by negative 3 over 7. So right now I have two negative fractions. Okay? Think of them as negative numbers. Before I do anything, I know that if I have a negative number divided by, so this is a negative number divided by another negative number, my answer is going to be what? Positive. We know that. So already I know in my head I'm going to have a positive answer. Now I don't have to write a plus sign in, because anytime there's nothing in front of the number, we assume it's a positive answer. The only other rule I have to remember now is when I divide fractions, the quickest and easiest way to do it is to turn it into a multiplication question. So what I'm going to do, I'm going to show you over here, is I'm going to flip the second term, so the second fraction, and I'm going to change this into a multiplication sign. So, negative 12 divided by 20. I'm going to change our operation to multiplication, and I'm going to flip that fraction. 7 over negative 3. Okay. Now what's happened is I've changed this into a multiplication question, and we already know the rules for multiplication. We did it just before. Multiply the top number by each other, and the bottom numbers by each other. So, negative 12 times 7.
84.
Good. Positive or negative? Good. Negative 84. 20 times 3. 60. Good. Positive or negative? Negative. Okay, so I have my answer. The only thing is I have a negative on the top and a negative on the bottom. What does that mean our answer should be? Positive. And remember, we said that before. We already knew we were going to have a positive answer. So, I can drop both the negatives and I have 84 divided by 60. Now, they've probably reduced the fraction in their question. Yeah, it looks like they've reduced it. Divide both by 12? Yeah. I can divide both of these numbers by 12 to get a lower fraction. I'm okay with it. If the question doesn't say reduce fraction to the simplest or lowest form, you can leave it the way you have it. They have, what they've done is they've divided the top and the bottom by the number 12 in the question. And they end up with 7 over 5. Okay?